The sensor senses or detects the change in process variable and converts the change into a mechanical motion or a physical change that is proportional to the change in the process variable. A sensor senses different parameters and transducer converts sensed variable to measurable variable or change in electrical parameters like resistance, inductance, capacitance, voltage, etc. as the output. A sensor is classified into two groups, active and passive. Do not need extra power supply. Need extra power supply. The transmitter measures the change in output of the sensor and converts that into a proportional signal. Transmitters for commuting 4 to 20 milliampere DC signals needs 24 volts DC power supply. The power supply can be provided in two different ways. Four-wire transmission, two-wire transmission, the diagram here shows how power is supplied in four-wire transmission system. The diagram here shows how power is supplied of two-wired transmission system. Receiver may be of three following types: indicator, recorder, and controller. These are available either in PLC, DCS, or as PID single loop controller.
बहुत ज़्यादा फालतू पेपर फेंक दिए।
Measurement process. Now, since we are aware of the elements of measurement system, let us see some of the measurement processes like temperature measurement, pressure measurement, flow measurement, level measurement, let us understand temperature measurement in detail. Temperature measurement or thermometry describes the process of measuring a current local. Temperature and or thermometry describes the process of measuring a current local temperature for immediate or later evaluation. The choice of sensor to be used for temperature measurement depends upon a number of factors such as temperature range, accuracy, speed of response, cost and maintenance requirements. For our steel plant applications, we use both electrical and mechanical sensors as following: thermocouple, RTD or resistance temperature detector, and thermistor are electrical sensors. FTS or filled thermal system is one of the mechanical sensors. In this part of the module, we will learn about thermocouples in brief. A thermocouple is a sensor that is used to measure temperature. Thermocouples consist of two wire legs made from different metals. The wire's legs are welded together at one end, creating a junction. This junction is where the temperature is measured. When the junction experiences a change in temperature, a voltage is created. The voltage can then be interrupted using thermocouple reference tables to calculate the temperature. In this part of the module, we will learn about thermocouples in brief. A thermocouple is a sensor that is used to measure temperature. Thermocouples consist of two wire legs made from different metals. The wire's legs are welded together at one end, creating a junction. This junction is where the temperature is measured. When the junction experiences a change in temperature, a voltage is created. The voltage can then be interrupted using thermocouple reference tables to calculate the temperature. Here are some salient features of thermocouples. Thermocouple consists of two wires of different metal alloys. It converts thermal energy into electrical energy. It requires a temperature difference between measuring junction and reference junction or the cold junction. They are also easy to use and obtain. The principle of this phenomenon is based on Seebeck effect. Thermocouples are active transducers. There are several types of thermocouples as the following table shows. Nowadays, nitrosyl, nisyl or N-type thermocouple with a temperature range of -200 to 1200 degrees Celsius is getting popular. let us learn about the need of cold junction compensation. In order to neutralize the effect of variation of ambient temperature of cold junction, the output of thermocouple is transmitted to the receiver. Cold junction compensation is carried out in combination of following two ways. First is by using a special wire called compensating lead wire. Through lead wire, cold junction is virtually transmitted to receiver side. And second is by voltage received at transmitter end that is being electronically compensated against ambient temperature at transmitter end. Now let us understand how thermocouples measures the temperature. A temperature measurement setup using thermocouple will consist of parts such as thermocouple is an active sensor, compensating lead wire or extension wire, and temperature transmitter. The output of thermocouple is measured by transmitting analog signal to the measuring instrument suitable for particular type of thermocouple, calibrated in terms of temperature. Otherwise, output of thermocouple transmitted to the temperature transmitter and converted to 4 to 20 milliamperes DC signal. Thermocouple, being a device, has advantages and disadvantages both. Use of thermocouples is simple and rugged. It functions well at high temperatures. It has low cost. There are no resistance lead wire problems. It comes with point temperature sensing. It gives fastest response to temperature changes. On the other hand, it also has some disadvantages like it is least stable and least repeatable. It has low sensitivity to small temperature changes. The extension wire must be of the same thermocouple type. The wire may pick up radiated electrical noise if not shielded. And it gives lowest accuracy. In this part of module, we will learn about thermistors in brief. A thermistor is a device which works in the same manner as an RTD but with a few changes. For example, the thermistor is more sensitive as compared to RTD. There are two types of thermistor, NTC and PTC. In NTC, resistance decreases with increase in temperature. In PTC, resistance increases with increase in temperature. Thermistor is non-linear in nature. The operating range of a thermistor lies within minus 200 degree to 360 degrees Celsius. Now, let us understand how signal conditioning takes place in thermistors. The thermistor exhibits a large change in resistance with temperature. A bridge circuit is used to compensate for the non-linear nature of the thermistor. Care must be taken to make sure that the power dissipation in the thermistor does not exceed the limits specified or even interfere with the environment for which the temperature is being measured. Like RTD, dissipation constants are quoted as the power in milliwatts required to raise a thermistor's temperature 1 degree Celsius above the environment. In this part of module, we will learn about resistance temperature detectors. Resistant temperature detectors RTDs are wire wound and thin film devices, nearly linear over a wide range of temperatures, can be made small enough to have response times of a fraction of a second, require an electrical current to produce a voltage drop across the sensor. RTD works on the principle that its resistance changes in proportion to change in input temperature. Most widely used RTD is PT100, which is made of platinum and has 100 ohm resistance at 0 degrees Celsius. Thereafter, its resistance increases linearly with temperature. The increase in resistance of PT100 RTD is 0.385 ohm per degree Celsius rise of temperature. Also, RTD is a passive transducer. Now, let us look at wire connections of RTD. There are two types of lead wire connections: two-wire connections and three-wire connections. In industry, normally three-wire type RTDs are used because third wire in three-wire type RTD reduces the measurement error due to lead wire resistance. RTD also has advantages and disadvantages both. Resistant temperature detectors are most stable over time, most accurate, most repeatable temperature measurement, very resistant to contamination or corrosion of the RTD element. Some disadvantages of RTDs include high cost, slowest response time, low sensitivity to small temperature changes, sensitive to vibration, decalibration if used beyond sensors' temperature ratings, and fragileness. In this part of module, we will learn about filled thermal system FTS in brief. A filled thermal system is basically a pressure gauge connected by small bore tubing to the bulb acting as the temperature sensor. The sensor is placed where the temperature is to be measured and the tubing connects the sensor to the elastic element. Thermal system consists of four main systems, namely liquid filled system, vapor filled system, gas filled system, mercury filled system. The measured variable in a filled thermometer is the total internal pressure. This pressure is the result of two factors, the temperature around the bulb and the ambient temperature around the rest of the system. FTS also has advantages and disadvantages both. FTS is the best choice for the areas where presence of electrical signal may cause fire hazards. Some disadvantages of FTS include slowest response time, high cost, and low accuracy.
Rồi. Ừ.
Now let us take a quick look at the concept of pressure measurement. Pressure is related to force. We can calculate one if the other is known by using the physics equation. That is, pressure is equal to force divided by the area or units of force per unit area. Pressure above atmospheric is mostly measured in pounds per square inch, that is PSI, or in kilogram per square centimeter gauge or absolute. For lower pressure, about 10 psi, inches or centimeters of water or mercury column are frequently used. For near atmospheric pressure, we refer more commonly to millimeters of mercury column or torr. The following table shows the value of pressure in different measuring units, and these can be converted into one another. There are two major types of pressure sensors as following. First, wet type sensors. Barometer and manometer are examples of wet type sensors. And second is dry type or elastic sensors. These include mainly three following sensors: Bourdon tube, diaphragm, and bellows. Click on each to learn more. Manometers are frequently used in the field or lab to measure the pressure directly. It uses a column of liquid to both measure and indicate pressure. These are used for low pressure. It can measure only gauge pressure. A mercury barometer has a vertical glass tube closed at the top, sitting in an open mercury-filled basin at the bottom. It is used to measure atmospheric pressure. The Bourdon tube is an instrument for measuring the pressure of gases or liquids, consisting of a semicircular or coiled flexible metal tube attached to a gauge that records the degree to which the tube is straightened by the pressure of the gas or liquid inside. The diaphragm is usually very thin and perhaps made of rubber. It expands when very small pressures are applied, and this movement is transmitted to a pointer on a tile through a fine mechanical linkage. Capsule consists of two diaphragms. Bellows look like a small can with flexible sides and a rigid top and bottom. Process pressure makes the unit expand or contract that results in the movement of the pointer. The bellows are usually limited to measurements from 0.5 to 70 psig. The diaphragm is usually very thin and perhaps made of rubber. It expands when very small pressures are applied, and a mercury barometer has a vertical glass tube closed at the top sitting in an How do we get to know the pressure measured by sensors? The instrument that sends the measured pressure data forward are called pressure transmitters. Pressure transmitter houses the pressure sensing element and transmitting element in one unit. Size, material, and sensor type depends upon the range of the pressure to be measured. The mechanical actuation of the pressure sensor caused by the pressure variation is converted into an equivalent electrical signal in the range of 4 to 20 milliamperes by the transmitter. It requires a DC power supply of 24 volts. As the world is becoming smart with technology, we also have smart transmitters. Smart transmitter is programmable and generally microprocessor based. It offers configuration flexibility and provide bidirectional communication capability. User can reconfigure or check configuration by using a portable communicator. Transmitter and communicator communicate through digital signal based on specific communication protocol. Smart transmitters also feature temperature compensation for increased accuracy, stability, and self-diagnostic capability. And what protocol industry is following these days? It is HART, that is, Highway Addressable Remote Transducer. The type of transmission in HART is Frequency Shift Keying, or FSK, in accordance with Bell 202 relating to the transfer rate and frequency for bit information 0 and 1, which is 2200 Hz and 1200 Hz respectively. In this part of module, we will quickly go through the concept of flow measurement. In process industries, measurement of rate of flow of solid, liquid or gas is required for accounting and automatic control purpose. Flow is generally measured inferentially by measuring velocity through a known area. With this indirect method, the flow measured is the volume flow rate as stated in its simplest terms. QV equals to A multiplied by V. In this equation, A is the cross-sectional area of the pipe and V is fluid velocity. Common units that are generally used in flow measurement are given below. 1. Cubic meter per hour. 2. Normalized cubic meter per hour. 3. Liter per minute. 4. Ton per day. 5. Kg per second. 6. Million gallons per day. 7. Cubic feet per second. Let us look at different methods of flow measurement as follows. One is restriction types, and there are few other methods. Click on each to know more. Under restriction types, there are two categories: variable differential pressure or constant area method and constant differential pressure or variable area method. Constant area method includes orifice plate, venturi tube and flow nozzle, and variable area method includes rotameter. Click on each to know more. A concentric, sharp-edged orifice plate is the simplest, least expensive, and most widely used primary flow sensor. Venturi tubes exhibit a very low pressure loss compared to other differential pressure head meters, but they are also the largest and most costly. Flow nozzles may be thought of as a variation on the venturi tube. The pressure drop of a flow nozzle falls between that of the venturi tube and the orifice plate. If we compare orifice plate and venturi tube, we will find that the venturi tubes are more expensive and accurate. Also, the pressure drop is negligible in venturi tubes, but the installation is quite difficult. In this method, the differential pressure remains constant while area changes with change in the flow rate. Variable area flow meters, also known as ratometers, are typically made from a tapered glass tube that is positioned vertically in the fluid flow. A float that is of the same size as the base of the glass tube rides upward in relation to the amount of flow. In most rotameter applications, the flow rate is read directly from a scale inscribed on the glass. Under other methods, there are magnetic flow meter, turbine flow meter, and ultrasonic flow meter. Let us learn about the most important magnetic flow meter. This is most suitable for the application where pressure loss in the flow line is not desirable. This is used with all aqueous solution with a minimum conductivity value of 5 microsiemens per centimeter at temperature up to a maximum of 1000 degrees Celsius, as flow meter up to 1130 meter cubic per hour in closed pipe application. Do you know on what principle does a magnetic flow meter works? Well, it's Faraday's law of electromagnetism. The liquid passing through the device represents a conductor moving through a magnetic field. It thereby induces a voltage perpendicular to both the magnetic field and direction of flow. The voltage is proportional to the mean flow velocity. Hence, the formula deduced is E equals to B into L into V volts, where E is induced voltage, B is magnetic induction, L is length of conductor, and V is velocity of conductor. In this part of module, we will take a quick look at the concept of level measurement. There are two main methods of level measurement, that is, direct method and indirect method. Direct method includes sight glass method, bobsling method, and flow method. And indirect method includes TPT method, capacitance method, ultrasonic level detectors, radiation level sensor, and air bubbler method. This consists of a graduated glass tube mounted on the side of the vessel. As the level of the liquid in the vessel changes, so does the level of the liquid in the glass tube. Measurement is a simple matter of reading the position of liquid level on the scale of sight glass tube. The simplest of the direct devices for liquid level measurement is the bob and tape. The bob is lowered to the bottom of the vessel containing the liquid, and the level is determined by noting the point on the tape reached by the liquid. The actual reading is made after the tap is removed from the vessel. Obviously, this method is not suited for continuous measurement. In this method, the primary device is a float that, because of its buoyancy, will follow the changing level of the liquid, and the mechanism that will transfer the float action to a pointer. TPT stands for differential pressure transmitter. It is used when the liquid is in a closed pressure vessel to balance the vessel pressure. The top connection is made to the low pressure column of the meter and the bottom connection to the high column pressure. The difference in pressure detected by the meter will be due then only to the changing level of the liquid. In this method, the level is decided by the final capacitance of electrode. The value of capacitance between two plates can be calculated by the following formula. C equals to multiplication of epsilon and area divided by D. C equals to epsilon into A divided by D, where epsilon symbol E is dielectric constant of medium, A is cross-sectional area of plates, and D is the gap between the plates. In this method, the ultrasonic level transmitters are placed above the surface of the liquid, which emit ultrasonic pulses at high frequency through the air towards the liquid or solid. The level is decided by time taken by transit and receive time of ultrasonic ray. The calculations can be done through the following formula. T equals to half of the multiplication of C and T. T equals C into T upon 2, where T is level of the liquid, C is velocity of the sound, and T is the time taken to transmit and receive. The most common reason for using this is that sensor does not come in contact with the liquid being measured. The radiation beam must pass through a path in the liquid as well as the tank walls. The liquid reduces the amount of radiation received by the detector and is given by the formula I equals to I naught E minus alpha into D, where I is intensity, I naught is intensity at no liquid, alpha is absorption coefficient of liquid, and D is the thickness of the liquid. If the process liquid contains suspended solids or is chemically corrosive or radioactive, it is desirable to prevent it from coming into direct contact with the level transmitter. In these cases, a bubbler level measurement system which utilizes a purge gas is being used. So far, we were learning about different instruments used in industries. In this part of module, we will understand about the concept called process control. But before that, let us go through an example of controlling the process of making hot process stream into cooled process stream. Cooled water comes in through a control valve and cools down the hot process stream in the heat exchanger. The sensor senses the temperature of hot stream and transmits it to controller. The controller compares the set temperature and the sensed temperature and accordingly controls the cooling water valve. Let us now understand the different aspects of process control. Control system can be of two types: manual control and automatic control. Automatic control makes the control system less dependent on operators. It is further divided into two types: logic control or digital control and closed loop control or analog control. Closed loop control can be done in three ways, that are feed forward control, feedback control, and cascade control. The following is the simplified block diagram of process control. It is basically describing the workflow of process control. First, the process starts and a lot of disturbances get along the output. The state of the process is measured by the sensing units. This measurement is compared to the desired value or state in the controller. The controller responds in a predefined way to reduce any discrepancy between the desired and the given state of process. The output of the controller is translated by a correcting unit called control element to alter the state of the process. Control valve is one such example of control element. The block diagram here shows values with respective device in closed loop system. Now, let us understand about the most important part of control system, that is, the controller. A controller may provide any one or combination of the following actions: on, off, proportional, P, reset or integral, I, rate or derivative, D. According to combination of actions selected, a controller may be P, PI, PD or PID controller. There are different equations for different types of controllers. Proportional controller or P equals to addition manual bias PS with multiple of K and E, where K is gain and E is error. The equation for integral controller or P equals to division of K by T multiplied by integral value of time, where T is integral time. For derivative controller or P equals to multiple of K, T and differential error, where T is derivative time. The two following systems widely used in industries: first, DAS, that is data acquisition system, which acquires all process parameters and status of various equipment in a computer-based system, and second, SCADA, that is supervisory control and data acquisition. It is a computer-based system for gathering and analyzing real-time data. SCADA systems are used to monitor and control, logic control, a plant or equipment in case of emergency. Let us now understand about few equipment that play an important role in process control, like control valve, IP converter, and valve positioner. Click to know more. Control valve is also termed as the final control element. The opening or closing of control valves is usually done automatically by electrical, hydraulic or pneumatic actuators. Positioners are used to control the opening or closing of the actuator based on electric or pneumatic signals. A control valve is made up of different elements. Click to know more. A control valve looks like this. And these are the major parts of it. An IP converter is an important element of a control loop. Its function is to convert the output of an electronic controller to the pneumatic signal that is necessary to operate the diaphragm actuated control valve either directly or through valve positioner. The function of a valve positioner is to maintain the control valve plug at a position that is directly proportional to its controller output pressure. A valve positioner is an accessory to an actuator that provides closed loop control of the valve's position. A positioner is mechanically linked to the valve stem and compares the command signal to the valve with the actual stem position and corrects for error. Because of the large volume of air required to operate the valve, the positioner must have an independent regulated air supply.
क्या लिखा ना ऊपर यहाँ लिखा ना हाँ इतना है हाँ अगले में क्या है ये पिस्तौल है आधा पिस्तौल पंजाबी तो यही है पिस्तौल ये ना तो मुझे लग रहा है पकड़ी में बढ़ा दो यहाँ मुझे तो ले लो 9 रुपए किलो ली है किलो में तो वही रेट पड़ेगा साढ़े का भी तो कितना पड़ेगा 1 किलो ले लो 2 किलो अभी यही तो आपको स्वाद निकल रहा फिर उठा के रखना दवा
Let us look at the three characteristics of control valves as following. First, linear. Second, quick opening. Third, equal percentage. This graph shows the comparison of all three characteristics. Click next to know how shape of trim determines the valve characteristics. Look at the shape of trim in the following diagrams of fast opening, linear and equal percentage. the difference in the shape of trim changes the valve characteristics. Let us now learn about different types of control valves as following. First, globe valves. Second, butterfly valves. Third, ball valves. Fourth, single-seated and double-seated. And fifth, direct acting and reverse acting valves. Global valves give best suited control along with a linear and equal percentage output. There are two recommended uses for globe valves. First, throttling service or flow regulation, and second, frequent operations. There are other applications as well, like liquids, vapors, gases, corrosive substances, and slurries, etc. Globe valves provides efficient throttling and accurate flow control, but high pressure drop and being expensive are two major disadvantages. Butterfly valves also give best suited control along with a linear and equal percentage output. There are three recommended uses for globe valves. First, fully open or closed or throttling services. Second, frequent operation. And third, minimal fluid trapping in line. There are other applications as well, like liquids, vapors, gases, and liquids with suspended solids. Butterfly valves provides low cost and easy maintenance, high capacity, good flow control, and low pressure drop, but high torque requirement for control and prone to cavitation at lower flows are two major drawbacks. Ball valves give best suited control along with a linear and quick opening. There are two recommended uses for globe valves. First, limited throttling, and second, higher temperature fluids. There are other applications as well, like most liquids, high temperatures, and slurries. Ball valves provides low cost, high capacity, low leakage and maintenance, and tight sealing with low torque, but poor throttling characteristics and proneness to cavitation are the two major drawbacks. If we classify control valves based on plug, we will get two valves as following. First, single-seated control valve, and second, double-seated valves. If we classify control valves based on opening, we will get two valves as following. First, direct acting or spring retract, air to close normally open control valve. And second, reverse acting or spring extended, air to open normally closed control valve.
तुम लोग खा लो, हम बाद में खाएंगे। 12 बजे खाएंगे। 12 बजे खा लो। बताते हैं तो सुना तो ऐसे नहीं, ऐसा खाता है। आ रहे क्या हुआ? प्रेशर लो था, प्रेशर लो है। तो फिर जरा लगते हैं इधर लो है। पहले ये अभी तो मतलब क्या है ना, इसमें कलर कॉपी लेके दिया था यहाँ से हुआ, हम कल उठाए कॉपी ले सकता है कॉपी में पानी करने लगा मुझे मिला हो में हाँ तो इस्तेमाल हुआ।